Okay, another reaction we would see with enolates is a reaction called the aldol reaction. Now I'm writing this in all caps, but the fact is, aldol is not a proper name or a proper noun. So if I were writing it in a regular sentence, I'd call it the aldol reaction. So aldol is not capitalized. What is the aldol reaction? The aldol reaction is where we make an enolate. No surprise there. We've been talking about enolates. And of course, an enolate is a nucleophile. And then we react our enolate. The enolate then attacks a carbonyl. Okay, that's kind of cool. So we made this strong nucleophile, and then we react it with another carbonyl, which is an electrophile. So how does this work? For the aldol reaction, and there are actually two different flavors of aldols. We're talking about the reaction. We'll introduce another one later. For the aldol reaction, the base we use for the enolate must be LDA. So here's our ketone, our favorite pet ketone, acetone, because it's small. We're going to react this with LDA. Let's not draw out the whole structure, just use this as a base. So B- comes in, plucks off our alpha hydrogen, dumps the electrons in that carbon, and we will draw our enolate. And of course we know our enolate's a good nucleophile. Now we're going to react it with an electrophile. So the first step we deprotonate, then that means the second step is coming along. We're going to react this with another carbonyl. This other carbonyl is almost always an aldehyde. Now you'll see a lot of examples on the internet where people don't do aldehydes, and a lot of them simply don't work. So almost always we will have an aldehyde reacting here. Well, then aldehyde is a weak electrophile. Hey, that's okay. We just made a strong nucleophile, or enolate. So this enolate will attack the carbonyl, and now we're in very familiar territory. We know what happens when you attack a carbonyl. It might roll off your lips, or maybe not, but when you attack a carbonyl, you make a tetrahedral intermediate. And here's our tetrahedral intermediate. Let me put our lithium in place here. There's our lithium. So this is, properly speaking, it is a tetrahedral intermediate. Now, you wouldn't call this a tetrahedral intermediate if you're focused on what happens to our ketone that formed the enolate. But the fact is, we attacked a carbonyl. Attack a carbonyl, you get a tetrahedral intermediate. So those are alpha carbon, and our alpha carbon is now connected to this tetrahedral intermediate carbon. What do we do with a tetrahedral intermediate? Well, in the past, we've always protonated. So we're going to have a third step where we add water so that we can neutralize our tetrahedral intermediate. And this is the final product for an aldol reaction. In fact, this type of product has its own name. People call it a beta hydroxy ketone. Why do they call it a beta hydroxy ketone? Well, the position of the hydroxy group is beta relative to our carbonyl. And so when we think of our carbonyl, we think of both of the oxygen and the carbon, and so the next door carbon then is our alpha carbon. So this is the aldol reaction. This reaction will always use LDA when we do the aldol reaction, and will always react with an aldehyde. When we do it, that will be our electrophile. But it's a great way to stitch together larger carbon molecules. Again, we made this new bond between the alpha and beta carbon. So this thing works great, and it's a very popular and important reaction in organic chemistry.